Hey there, guys. Welcome to day 2 of SAT prep. I'm going to go ahead and just get started. Hopefully, you have already completed the quizzes and now we're looking at the answer keys. So, I picked these problems because there's some good strategy involved in these. The technical part, for some of them, is not necessarily the hardest part, but there is some strategy because, as you know, SAT is time based. So, some of these. Um, you could get up in a timing issue. Okay, so let's go ahead and get started. The first one says, which of the following is an example of a function whose graph in the xy plane has no x-intercepts? So there's obviously no calculations here. And actually, I should have said the first three problems were no calc. So what we're looking for here is the key here is x-intercepts. Okay, has no x-intercepts. So we know that x-intercepts are visually when the graph crosses the x-axis. We know algebraically that it's when y equals 0. Okay, so when it crosses the x-axis, that's when y equals 0. Okay, so what this is really kind of testing you on is vocabulary more than anything. No x-intercepts also means no zeros. Okay, and the reason I'm talking about zeros is if you look at the options, and this is one of the overall strategies for SAT, is looking at the options. The options can give you a hint as to how you should approach the problem. Okay, it might be the format, it might be the vocabulary. In this case, they all say zero in them, right? Zero, 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 zero. The difference may be is we have a not zero, we have with real zeros, with no real zeros, with at least one real zero. So I want you to also think of it as looking at the option choices to help you. So no x-intercepts means no zeros. So because intercepts are going to be the same as zero, right? A zero is when the function, you set the function equal to zero, you set y equal to zero, and you solve for it. So if there's no zeros, then we can get rid of b because that has a zero. We can get rid of d. So we're left with A and C. Okay. The obvious choice here is C because it specifically says no real zeros, and that is the correct answer. However, if you're not convinced on A, let's just take a quick look at it. A linear function whose rate of change is not zero. A linear function is a line. If it's not zero, that means the graph is either going to look like this, because that has an undefined slope. So remember, rate of change is the same as slope. Or it's going to look like this, or it's going to be negative and look like this. All of those are going to cross the x-axis. Okay, all of those have x-intercepts. All of those have zeros. So that's why we can also eliminate A, and it leaves us with C. Okay, moving on to the next one. So you're given two equations here. If you take a look at it, one of the things I always do is say, okay, I see a parabola and I see a line. All right, it says xy, if xy is a solution, and x is greater than 0, what is the value of xy? So because this is non-calc, you can't just graph this in your calculator, right? So we need to do a little bit of work here. The key to saving time on this is recognizing that y is equal to x squared, which means you can substitute that in right there. So that's what I'm going to do first. I'm going to substitute. I'm going to get 2x squared plus 6 is equal to 2 times the quantity x plus 3. And I'm just going to multiply this out, combine like terms, etc., and see what I get. Move everything to one side. Now look what happens here. Your 6's actually end up canceling out. If you subtract 6 over, they're going to cancel out. And we're here now. Well, let's keep going because if we have to know the value of x times y, we probably need to know the value of each. So what you do here is factor out the 2x. So GCF right here. And you get 2x times the quantity x minus 1 equals 0. And then zero product property says that if you multiply two numbers and the product is 0, at least one of them must equal 0. So set them both equal to 0 and solve. Okay, so we get two answers. However, look back to the original problem. It says x is greater than 0. So this cannot be an answer. So this is what our x is. Great. Well, now we have x. We can go back and get y. using the first equation. Y is just equal to 1 squared, so y is equal to 1. So the question again is asking for the value of x times y. Well, x times y is just 1 times 1. So x times y equals 1. That's how we get A. All right, moving to the next one. So this one says which of the following is equivalent to 9 to the power of 3/4. Now, there's a lot of different approaches to this. Okay. I, in my head, initially am thinking change it into a radical because I see radicals in the answer. Okay. So if I do that, I know that the bottom number is the root and the top number is the index. So if I change that into a radical, the root goes on the outside and then the index goes on the inside. I also know that that's equivalent um, to the fourth root of 9 all to the power of 3. Okay. I look at my answer choices. I don't see that. Okay. So I know that there's somewhat of a, not a trick, but a way to manipulate this to make it look like something else. However, I can right away eliminate something. And elimination is a big thing. Okay. Especially if you're not totally sure, you absolutely want to eliminate what you can so that if you are guessing, you're only guessing from a smaller number. Okay. So because we know it has to be one of those, it cannot be A because that says the cube root is 3 of 9, and there's no way we can get that. And it's not going to be B because that's just the fourth root of 9, and we know it's a fourth root of 9 cubed. Now, we're pretty sure it's not C. Okay, so if you're running out of time, or if your gut's telling you there's no way it could C, the answer is D. You are correct. But how could we actually prove that, right? Now, this is one where I probably would just use elimination and go with D because there's just no way it could be any of the other ones. Okay, but if you're not positive, you have the time, how can you show that it's D and not C? Well, let's think about this. C as a rational exponent would be 3 to the power of 1 half. D as a rational exponent would be 3 times 3 to the power of 1 half. Okay, well, those still do not equal 9 to the power of 3/4, right? And so what we're trying to figure out is which one of those is actually equivalent. Well, here's how it actually works. 9 to the power of 3/4 is the same as 3 squared to the power of 3/4. Okay, and then properties of exponents say that this is also the same as 3 to the power of 6/4, which if you reduce that or simplify it, you get 3 to the power of 3/2. Okay, well now turns out that you can now break this up, and this is the part that's kind of hard to see, but this is the same as 3 to the power of 2 over 2 times 3 to the power of 1 half. And we're working backwards a property of exponents, right? Properties of exponents say that if we add 2 halves and 1 half, if we have the same base with 3, we can add the exponents. So 2 halves plus 1 half does equal 3 halves. Now, turns out this is 3 to the power of 1 times 3 to the power of 1 half. And now look what we have. This is equivalent to this. And that's how we can actually prove that D is the correct answer. However, again, I'm not sure that I would spend all that time on that. I would eliminate and by default choose D as my answer. Okay, let's move to the calculator questions. First one here, it says which of the following ordered pairs satisfies the system of inequalities. To be honest with you here, the two approaches I would use here is either graph on your calculator, if you have a calculator that can graph and you feel pretty good about graphing inequalities, or I would work backwards. So I would substitute answer choices in. Okay, and one thing you could do, right, you'd want to do, even whichever option you're using, is change this so it's in terms of y. Okay, so that they're both in terms of y. So this would be negative y is greater than negative x plus 1. Divide everything by negative 1. You have to flip the sign when you divide by a negative number. So it's y is less than x minus 1. So if you were to graph it, you'd be graphing these two. And if you're going to substitute it in, what I mean is you're basically going down the list and there's no rhyme or reason which one to start with, A, B, C, or D. Some people like to start with A and just go down. Some people like to go backwards. But you're plugging these in, and remember, if it satisfies the system, it has to satisfy both equations or both inequalities. Turns out your answer here is D. Okay, and that because this is calculator work, right? You can plug this, you can use your calculator to substitute these in and find that D is the only one that satisfies both. Okay, number 5. It says in the equation above, A is negative, B is positive. Which of the following must be true? So if you look at your answer options, you're looking for what C could be. C is greater than 1, equal to 1, equal to negative 1, or less than negative 1. Couple ways to approach this. So I initially just look at it. I'm going to separate this out, okay? Meaning I'm going to rewrite this as two separate fractions. So A divided by A minus B divided by A, which equals C. Well, A divided by A is just 1. So 1 minus B divided by A equals, C. Okay. And then I can leave it like that, or I can rewrite it again. But let's just leave it like this. Okay. So we know that, again, B is positive. All right. And I skipped that part. A is negative. So let's just talk about this right here. All right. B over A. So this means that A is negative, so it's going to be a negative number down here. B is positive, so it's going to be a positive number on top. Well, positive divided by a negative means that it's going to be a negative number. All right, so now we have 1 minus some kind of negative number. Well, when you subtract a negative number, you're adding it. So it's going to be 1 plus a positive number equals C. Well, there's some number there that's not 0, so that to me means it could be anything, 1 plus 1, 1 plus 18, 1 plus 1,000, which means that C has to be greater than 1. Okay, another way to look at it is starting right here. Rewrite this now so it looks like this. 1 minus C is equal to B over A. Again, we know that B over A must be a negative number because of the work we did previously. So 1 minus C is equal to a negative number, which means 1 minus C has to be less than 0, right? Because 1 minus C is equal to something negative. And then if you rewrite that in terms of C, you're going to get C is greater than 1. Okay, so we got it in both ways. Okay, finally, last problem. It says in the equation above, A is a positive constant, and the graph of the equation is a parabola. Which of the following is an equivalent form of the equation? Okay, so this one technically isn't too terrible, but there's a common mistake here. A lot of people would maybe pick A here. But what I like to do is, I look at my answer choices. Well, I know that if I multiply these all out, they're all going to give me x squared to start with. So that's not going to help me. I need to look at the second term. I need to know, how do I get negative A? Okay, so if I do this, right, so I'm just kind of looking at the second term. How to get to the second term. If I multiply, what I'm going to do is I'm going to look at this and this and this and this. Because I know when I distribute, that's what I'm doing. Now remember, this is the same as x plus a times x plus a. Okay, so if I just multiply that last term, what do I get for each of these? Well, here I'm going to get negative a squared. Here I'm going to get negative a. For C, I'm going to get negative a squared over 4. And for D, I'm going to get positive a squared. Right, and so what I'm doing is I'm just multiplying a in option A times negative a gets me negative a squared. In option B, root a times negative root a gets me negative a. Okay, so the only one that is equivalent to the equation above is this one. So there's my answer, B. Now you may have, and I actually did do this, but you may have already eliminated D. And that's because you're going to get a middle term there. Right? And our equation above does not have a middle term. So you do need two binomials where the middle term will cancel out, which means that one has to be positive and one has to be negative. So Right away, you could have eliminated D and then only had to choose between A, B, and C. Okay, that's all we have for today. Hope those made sense. Email me with any questions. Thanks.